Good morning, all. Welcome to the last day of 5-day SCTP on softwares used for research in mechanical engineering. Today, we have our resource person, Sudhi Krishna KP Madam, and she had done BTech in Electronics and Communication Engineering, then MTech in Signal Processing, which is an interdisciplinary subject, and finally, she had ended up with doing research at IIT Madras in mechanical engineering. So she could talk more about the interdisciplinary mode of research, that the scopes in those particular areas. And she had done works related to the non-destructive testing, the thermal analysis and image processing, the laser image, etc. Then she has skills in AI, then deep learning, machine learning, etc., and some of the softwares related to mechanical engineering also. So now she's here to deliver her thoughts are related with the software COMSOL, and she'll be delivering her research experience in that particular area also. So I would like to use this opportunity to welcome her. Over to you, madam.
Thank you, Professor Antonio Joseph, for the kind introduction. So, good morning, all. Sir, shall I share the screen now?
Yeah, you can start.
Hi. Like before moving into the console or introduction to the console, like first we are using all the simulation softwares and this called why we need the simulation software, like why we need the simulation. So in as with my research experience and all, and in our research group we need simulation or this modeling to validate our experiments, or we need to understand uh, we need to understand the intuition for the further innovation. Like we can go directly into the environment or harsh environment or thermal plants or nuclear plants or anywhere. We can go directly or get all the samples for the study. So what we will do, like we will get few samples. We are accessible only to few samples. So in that condition, we need to do an extensive study with a different operating condition, with a different parameters and all. So before moving into the practical or physical prototypes, we will do an optimization of our model, and then we will validate with our experiments. So, and also uh, there may be a we can't predict what will be the outcome, like for the what will be the outcome if we do in that a real scenario, or in this in the real experiment. So before that, it will be better to do a simulation in simulation. So you may be knowing different simulation softwares, no, simulation software, but in our research group we do move with the COMSOL and Abacus, ANSYS, these softwares. So I'm using more on more with the, using COMSOL, COMSOL regularly, like to create my create data for the data analysis, like image processing, AI and all and AI. And why we need to use the console multi-things, like we can optimize and verify the real world process with the simulation, and we can incorporate multi-physics like heat transfer and acoustics, vibration and acoustics, and we can and use a structural analysis, and like different sorts of in different engineering fields we can apply this simulation. And it's really user friendly and flexible from the design, then analysis, post processing in, and that it's building into an app or application. It is really flexible and a far flexible simulation software. So here we can see a few engineering fields. Electromagnetics we can study on that using the COMSOL multiple physics. Then in acoustics, chemical engineering, heat transfer, fluid flow, structure mechanics, equation-based modeling. Like you can manually enter or customized modeling you can build, and multiphysics. Like you can incorporate both electrical and heat transfer, vibration, and acoustics, like that. So coming into the simulation workflow, in the console, first we need to set up the model environment in which in which study what study you are going to do, and like which environment or heat transfer, electrical or structure mechanics you need to set, and also whether it is time dependent or it is stationary or any customized. Then you need to set the geometric objects like a 3D structure or a 2D, and you need to specify the dimensions. Then you have to define the material properties and all the physics boundary condition for your physics. Then you have to create the mesh. Meshing you already know. The whole of the structure is divided into small meshes, like in either in different shapes like tetrahedral or triangular in meshes, and based on your accuracy, based on your accuracy or your need of the data, you need to optimize that mesh, and we need to run the simulation, and we can post process the result. Either we can extract the result from the console, and we can do analysis in the Excel, MATLAB and all, or you can view the results, or you can analyze the results in the console software itself. So we can move on to create one model. Here I will be introducing you a two-layer model, three-layer model using the heat transfer. So we can study the how the heat connection from the surface, and I will be giving a heat pulse or the heat input on the surface, on the top surface of the object, and we can study how the heat is transferring through the object and it reaches the next surface. So here, when we open the um, uh, desktop user interface of the console, we can see model wizard and blank model. So model wizard, you have the options like 3D, 2D symmetric, 2D, 1D, 1D axisymmetric, 1D and 0D. So you can choose whichever space dimension you want according to your application. So here we can choose the, I mean, I'm choosing 3D. Then we need to add. I mean, either you can add here, or you can move directly into the GUI, and you can add from the ribbons you can see here. So here it is available AC/DC, acoustics, different options will be there. According to your application, you can add that. And electrochemistry, fluid flow, heat transfer, optics, plasma, radio frequency, or mathematics, structural mechanics, anything. So I will choose heat transfer in solids. You can add both AC/DC. One of the options in the AC/DC and heat transfer, that is multiphysics modeling. So for the ease of introduction, I will be adding only the heat transfer. Then move on to the study. So here your preset study options are stationary, then thermal perturbation in frequency domain, time dependent, and you can custom studies you can have, or you can move directly into the empty study. So I will be using time study because I want to see how the heat is transferring with the time. I will be applying a small duration of pulse at the beginning of the study, and then how the heat is transferring in through the object with the time. So I will be using this time study. Then time dependent study. So yeah, here you can see the ribbon with all the options at once. Like this is application builder. That is, once your modeling is done, you can build it to an application. And that part I am not covering. You can check later if you have, if you are doing this. And here, so all are in the same ribbon here, or you can explicitly go into the definition, geometry, materials, physics, and all. We can see that. So in this model tree, this is here you can name your model. Now it is in untitled.mth. It will be like this. And global definitions are all the definitions of materials and parameters. It will not be changed, or global parameters we can define here. So then component section will be having definitions, geometry, heat transfer. Since I have added the study, yeah, physics, like heat transfer, then the meshing, then study, time dependent, and result section. Now it will not be, there will not be any values here. Once we run the simulation, we can see the results. Then so first we will go on to the geometry session. So I told you we are building two-layer structure. So first I have taken block one. So here the type is solid, and we can set the size and shape, position. and you can see a clock here. So you can drag like this and see all the circles and at this. And yeah, from here is your view. And if you want to go back to the view, you can see this and you can zoom in, zoom out. And if you want a snapshot, you can different in access view. You can explore all the options here for the view. You can see the transparent view. If you have entered any defects or any input materials you want, if you will, you can see through this transparent through this lighting. So I will be adding one more block, like block 2 with the I will be adding a thin layer on top of this thick layer. So yeah, here we need to I need to add on top of this. So I need to this axis is z axis, right? So I will be I need to add the first block. The height I have chosen is 1 meter, 1 millimeter. So we need to came on top. So two layers are there. So our geometry is you can form only images. You can it as a single object here. You can so geometry is done. You can move it and you can see. Then material. We need to choose which material you are going to assign. So here options are there like add material from the library, plan material. So in this library, you will be having built-in materials. Material library is there. Built-in materials like any material you can choose if it is available. So if that material is available in this library, you can add that, or you can add the blank material and assign. And for the since we have chosen as a metal, so we need to enter the values here, like thermal conductivity, density, heat capacity corresponding to each material, or you can choose this and you can add this, and again you need to add a material and you can enter the values for K, rho and Cp, or you can add in this here global definition you can enter, and you can add the like K value, and you can define here also K rho Cp corresponding to each object. So here I will be I will as of now I will choose a material, built-in material, like first one. Okay, okay, I will choose copper. So copper is added, and I can choose manually, or you can opt for all domains. Like you can choose both layers as a same material like copper, or you can choose it manually. So I'm choosing first one as copper. So and we have one more material like so. I will use as of now I will choose titanium. So titanium is added. So manually I'm choosing it as a second domain. Like this is called first domain, and this is called second domain. So if you choose manually, if you just click on that, you can see the second domain. So copper is assigned to the first domain, the bottom layer, and the titanium is assigned to the top layer. So next we will move to the heat transfer in soil. So here all the domains are by default it is um, assigned because we have entered the heat transfer as our study. So here a few data settings are there: ambient temperature, ambient pressure, relative humidity, and all. So here, by default 293.15 Kelvin is given. You can, or I want to set it the temperature, initial temperature as 300 Kelvin. So I will be adding in the global definition the parameter like 300 Kelvin. Initial, yeah, initial temperature as T0. So here, like, so, since if I have given it as a T1, it will be like this in this color, yellow, light yellow color. It's like unknown variable. So if you given T0, you can see that T0 Kelvin like that. So we don't need to change anything particularly other than this temperature. If you want, you can change according to your application. So solids, all both the domains 1 and 2 are solids. Then initial value here also we need to change the temperature as T0 Kelvin. And thermal insulation, like all the surfaces, these are our 1, 2, 3, 4. So here this model is named. So here this 6 is not applicable, means that in this the junction between those two uh, layers, top layer and bottom layer. This is not applicable because if it is thermally insulated, that heat transfer will not be there. So it is by default it is choosing it as a thermal insulation for this sixth layer, sixth boundary. So we will add heat flex. Heat flex. So we need to give an external heat source on the surface. Then only we will we need to apply the heat. Then only we can see the heat transfer through in this surface and um, through the two layers. So we need to give that. You see here inward heat flux is 0. So I'm as I said, I'm giving a short pulse for a few milliseconds. So I'm defining first heat flex Q0 says yeah. And also we need to set the duration, pulse duration, how long you are giving the heat pulse. So naming it as heat. 1 millisecond. So we are only giving the heat on this top. You can give whichever surface you want. Like I'm giving on top of the surface, or you can give on this. Then you can choose this surface, or if you want both surface like top surface and here, or you can if you want to apply the heat source on the back surface. Anywhere you can, and you can deselect this option. You can remove this. You click and remove the selection. So or you can give all boundaries also. So I'm giving on top of this surface. Next, we have to define the filters. Like in the all boundaries. Like before, this layer is not added. We default it is sticky. Then this value, heat transfer coefficient. Like the literature you will be getting, or you can try with the different heat transfer coefficient values. Here we are using 5. You can try it with different values, and the external temperature as we have defined already, it's T0. Yeah, we have set the all those heat transfer like invert heat flux, then convection. And we have defined this. In between, if you have any doubt in any of the option, you can choose this help and you can search. Next, we'll move on to the important one of the important section like machine. So, machine is a main component. Like it will decide how how much computation time, how much memory, and the accuracy of the result. And all depends on the machine. So, I mean, one of the factor is the machine. So here it is like element size. You can choose like extremely fine, extra fine, coarse, normal, and all. If I choose, and here you can set this. Then you can um, add free tetrahedral or I'm choosing free tetrahedral. More options are there: free triangular, free quad. Any mesh types you can choose. So by and any different shapes or those things you can choose and optimize the results. You can try different. Anyway, this is simulation. You can run n number of simulations and optimize that mesh and mesh size. You have to optimize it to validate it with your experiment results. So yeah, like for entire geometry, I'm taking. Then taking the step. So once I run this, so this is normal. Yeah. What I have chosen is I want my significant data or a significant data I'm measuring. If I'm measuring is from the top of the surface, when in the surface, in the same surface I'm applying and I'm measuring the temperature, I can just go for the squares mesh. So I have chosen for the swept. So that's what do with the swept option. Or if you want the whole uniform meshing, you can do for the entire geometry. You don't need to opt for the step. Then this is normal, so you can go for finer. Then you build it, yeah, become more finer. Like, and if you go on adding the elements of the mesh, it will take the computation time more and memory, and also you have to make sure your system is capable of all those memory allocation and all before. I mean, COMSOL is more like more memory greedy, you can tell like that. So for here, for the results purpose, we will mainly dedicate a system to the console and we will run that. So for the for all big models, and for small models, normal system is, but still you have to answer that. And so and you need to, and another point is you need to uh, check, like you don't need to go for extra fine or extremely fine. Some cases you will be getting that sufficient results or better results with the normal itself or coils or finer and all that. You have to do all that is mesh optimization. Like you have to do uh, all the sets of this thing, all the sets of all the meshes, and you can go for the customized also. Like you can set the maximum element size, minimum element size, how it goes. The curvature factor is how it goes in this curve features or in this edges, and you can customize that, or you can go for this according to your application. So here I have chosen fine, and you can see the result. And next we will move on to the time dependent story. So here I've chosen is as of now we'll choose the default, like from 0 to 1 second. It's in the second. You can change to a step also, different steps, and you can change the time unit also. So I have chosen is a time step in 0.1 second till 1 second. So yeah, I think if you have done any error, the model will automatically inform you before the modeling, I mean before simulation. So I think done all those steps. Yeah, next, yeah, one more thing there. You need to uh, like probes are there. You will be taking some probe to measure your data or measure the temperature. So domain point probe. So you can either choose by clicking on a click, or you can enter. So this is from here you can see it will be measuring the temperature with the time. So you can choose the probes like boundary probe, like a domain probe on a whole domain. You can measure the temperature or edges or the boundary point, or you can choose any options. So in this, choose choosing that, you can run the model, like compute the selected study. You can do from here, or you can go to the study and you can do that. before the messages like measures 3 times I have done machine, so it is showing the elements number of degrees of freedom also. Then progress it will be showing here. The purpose of the computation solution and it will show here and here it will show the memory allocation all comes from the statement and it is taking and all the status of the progress. Then prop tables, since I have just chosen one prop at 0.5 mm, 5 mm and 1.1 mm at each time step, how the temperature is varying. And now we will go to the um, plots. Here it is real time, it's showing how the temperature it rises to after the first in the from the 0 to 1 seconds. It's showing the yeah, it is showing the model. The can see you can set the grid and you can show the legends and the temperature only it's showing. You can set that. You can take the picture and yeah. And here it is. I will come on. I will come to this other analysis. First, we will see the temperature. It rises the surface temperature once the pulse is given. The surface temperature rises to the 311 Kelvin. So then this is convergence plot. How the while solving how much the how the error is reduced to the exact solution and to the calculated solution to the exact solution and it reaches once it is reaches here like your model is somewhat accurate. Like here it is dipping, the error is dipping, and you may already know how the conversion flow works while solving. So yeah. So this is 3D plot. You can go back to each time step, like clicking here, zero point 0.9 seconds, 0.8 seconds, how the temperature, you can see the variation. This is how. So you can see the plot in different ways. You can see by default it is conduit, the isothermal conduits are there. So, conduits. Since we have chosen only 10 steps like zero point 0.1 seconds from 0 to 1 second, you should have only. For the initial study, we will choose more steps, 10 steps. So, this is the problem. So, in choosing to reflect the data, here I will this is take it up and we'll go for the surface temperature. You can see how the surface temperature is changing. And you can choose, if you want the snapshot of this image, you can take this like if you take this option, you take you get this. You can include all those there, or if you can customize your this and the format also you can change. If you want, you can take that. And these are all the top load. If you want to export the data. You can take that or you can export from here itself, or in this option table is there, you can add table to export. Like from here only you can export or you can take the data from the console to the or to your machine or computer, and you can do the further analysis using Excel or MATLAB or any software you wish. So you can name it or some text file, and you can different file format you can see. Then yeah, like this. So, like this you can have. Then in the result section you can see a lot of options like one flow, polar flow, and cut plane flow and all. More options are there. So first I'll go to the animation. This player. So here this player will show how it will take. Since we have only 10 frames or 10 steps, it will show fast. Yeah, just to do that initial, we are giving the floods. It's like then if you want to save it, you can choose. Yeah, since we have only frames per second, and you can name the file and you can save it. Flash, AVI, any format you can save, and then you can all you can customize, and you can export. Then it will be saved in your system. So finish. Just it will be giving one thing to you, tables, derived values. Like here also you will see the derived values option. So uh, if I want the maximum value of the image, so volume maximum, so we will give the maximum volume maximum. Then like from this section you can get all these average temperature or maximum minimum, any sorts of value you can have, so that you can explore the data, the study basic studies, and this is the top solution that I have taken from this form that I have taken the table values. Then add, you can check now I will add will show this only from 0 to 300 to 300.35, it is right now. You can run for the more steps, like from here I'm showing only 0 to 1 second. You can go for more, like 10 seconds, 100 seconds in that. I will see, we can change be good if you clear all the existing solution and everything. Yeah, this table it's showing both the zero and time steps. Then on the top, on the bottom, it's in the top surface and it's in the bottom surface. And in this top plot, the entire temperature change since we have chosen the step as COMSOL, um, COMSOL 1, it's changing. So till this point, if you have any queries, you can ask. You can ask in between.
Madam, are you talking? I think your speaker is mute.
Hello, can you hear me?
Yeah, yeah, yeah.
Yeah, actually, I was waiting for the explanation. Yeah, you can see this. And can more. For analysis, we will be getting more values. Earlier we were having 10 values, 10 temperature values. Now we will be having, since we have added the reset and step, we will be having 100 frames. So, like this, you can add more, or and you can add till 10 seconds or 100 seconds and all. And since here we have gone for extra fine, okay, extra. So it's like I'm telling about the option of changing all those um, meshing, and we can check different meshing options, and we can extract the results, and we can see what is the options and how the it's an important step, like the mesh optimization. And if the result is not varying much, you can go for the finer or normal and all, or you can stick to the extremely fine, or more you can just customize it and even smaller, and you can see how the how your results are varying. And obviously it will take the time to take more time. Really, so here, okay, if you want, you can cancel this from here, or you can see if you find any errors in between this, you can cancel here. It will take time. So, um, okay, because it is want to show you how it is influencing your computation time, and it will take more memory also. It will show. and points and so on. And it's taking more time also. Yeah, and you can have different studios here, and few more blocks also you can add more onto this, or inside this block, or some kind of effects. Like in ND, we will usually we add some kind of different kinds of effects inside this structures. It's just a plane. We'll be having different blade kind of structure, or different structures for analyzing. And we will, yeah, here you can set the all the global parameters. Like you can, instead of adding the properties from the library, you can um, customize. Here we have chosen this copper, titanium and all from the library, and we have assigned the values. But instead we know from here, like for solids we need all those critical parameters like C2 and HK. So you can define here, like corresponding to like, and like that you can add, and you can, and okay, see the difference how to choose very, show how to add the basic. This will all belongs to the basic properties, or if you want some other property like models, electrochemistry, or in the case of acoustics, like velocity, local properties, you can add here. But here in our case, I will show you, we need basic properties like density. Since I haven't entered any values, we can enter here itself. Add here. So now the warning sign is not there, and the thermal here also you can add. Then yeah, the capacity at constant. Click here. Okay, and like this you can add, or shown layer. Here you can add like, and it will be seen here. Like that you can add this. So here I have chosen only heat transfer in solids like single physics. Then machine, you can choose for a different machine size. Option. And, you can choose different domains, and then you can vary that. Then deposits are there. Then you can add more blocks like structures, cones, spheres, and more on to this. And also important thing is, we can import the models, 3D CAD model, or any files to this uh, the console, and you can run your study, or do your studies on that. And so till this point, if you have any doubt, you can ask. So or you can, if you are not able to, you can type in the chat box. Yeah. So another important point is once we run the once we run the simulation, we will be having this value. We need to check that time stepping involved. We need to check whether this value will be below our time time step. Now we need to make sure. So for optimizing model, you need to do a lot of optimization, like you can just build a model and give study and all. Uh, we need to do a number of studies or optimization and we need to do. And also you may be unaware of, in our cases, in my case, uh, that material properties are not that not given, and also it's like the ceramic materials. So I will be doing that study, parameter study, and need to check the values, optimized values. So you can choose that parametric suite for that. So you can specify the parameter name, parameter value list, and you can here, for example, you can see initial temperature. Then insert 300, stop at 400. So what we can study at one instant, like you don't need to enter each time you need to run 300 for the initial temperature 300 Kelvin, then 310 Kelvin, then 320 Kelvin, like that till 400 10 times. You don't want to run the model, you can just enter this you can use the parametric suite option do analysis, like at once it will do all those analysis and it will provide the results. And you can add this, and you can add the unit also, you can add here, and you can add also that for all the, you can choose here, and it will give for the specified combination or all combination, and many options are there. It's really very user friendly, and you can try with a different combination, or you can extract the results from here and you can analyze it in Python or whatever, MATLAB or whatever software you are comfortable with. And you can specify, like yeah, here materials will also, you can run functions to, like different function you can give, and and also in the definitions we can give different definitions, I mean different functions, analytic functions or intelligent piecewise quotient pulse, any functions you can give, and different like according to your application you can give. Here also different thing is a liveling interfaces are another big option, like AutoCAD, SolidWorks, and different PTC Pro engineer. You can use that. Then another option is another, yeah, we can use the use with a server also, or we can here we will usually use, we will save this model to the MATLAB, and we will write the code instead of changing all those values, and you need to do this parametrics either in this model we can do, but if you want to do the specified um, list or in this combination, you can just save the model in the MATLAB code. Yeah, in the MATLAB. code you can get, and I'm not saving here, but you can see like and you can connect it to the server, and you can link with the MATLAB. Like here you can see you can and you can edit it with them in the MATLAB and use the server. And, yeah, importing is the metal planetary study. And another thing is, if you don't want to, if you want to study all the different inbuilt libraries are there available. So, mm, different things there. So, yeah, we choose it. So, which software you want to choose, this console or abacus or conform as you have we introduced to the conform in the class. It's like your choice. Like if you are more, if your work is more emphasized on the on that numerical models or mathematical modeling, then you have to be keen on different, I mean, each and every options here. It will be like not just like that and good answer you are applying about. You need to do more. Like if you just want to, I mean, if you are not having enough uh, experiment setup or experiment and like structures or samples you are not having, and it's restricted in your field, you can choose the console or in the abacus to build different models, and you can try different physics, and you can study this. This was just randomly chosen. Here it's showing as well. Since I have chosen this because like here in the study, it's already taken electric currents and its multiphysics model. Earlier we have seen the single physics like heat transfer. Here it is electric currents and heat transfer. Both they have done. It's in the tutorial of you can just open different. You can explore that once you have that application. Let's start using this. You can explore all these available options or models in this, and you don't want to just from scratch. You can study on different things. In this itself, inbuilt, it will be chosen. If you choose in the uh, in the beginning, if you choose what the studies you want, if you add that, by default, it will show some multiphysics like electromagnetic source or boundary magnetic source, and there's a couple, or you can add that physics like you tensor or add multiphysics or different multiphysics, and you can set that. Then this is application builder, like you can do. I'm not exploring into this. um, I'm not explore. You can these options are there, and you can switch. Here it is you are building that application based on the model you have done. We can switch to this model. Um, maybe introduction. It's- I think I have understood little bit, but it's like that steps and the order and all. The tutorial is there in the console site itself. They have good lot of tutorials to help you in different new things like field heuristics, heat transfer and all. In order to change your parameters heat and sleep is a important option. Then optimization is very important. Like you can't just build a model and you can just run different hundreds of models and just make your just going on different. You can't do that. You have to optimize it and it will do that. And yeah, so in our research, like we are doing both experiments and modeling, and we are taking those is for generating data and for further processing we are taking, and we'll be using extracting all those data from this and we'll we will build multiple data and we are studying all those sorts of um, like fitness study, material property study. So, Antonio, sir,
Yes, madam.
hello.
Yeah.
Yeah, I think introduction is um, so.
I didn't hear you.
Yes, hello.
I didn't hear you.
Yeah, this is introduction session. Introduction to COMSOL is done. If somebody is having any, we can after that.
Yeah, you're completely usage.
Yeah, yeah.
Okay,
Hello.
okay.
Yes, ma'am.
So
Yes.
now
Hello,
I
madam.
think
I have a
Yeah,
doubt.
sure. Yeah, sure. If
Can we add a multi
sorry, I can hear
in which
you.
all occasions in which all
Yeah,
occasions can we add
yeah.
this
Actually,
multi
like if location, like we in this study, we'll be having this part.
in which all
I will
occasions
open
in
this.
which all occasions can we add multi
Like in occasion meaning, see here, if you choose this, it will be a, sound. How the sound in this violin, you will be seeing the vibration and the sound acoustics. So and sometimes the heat and the electricity will be there. Like according to your application, you will be knowing what all those physics are included. So based on your application, you can add that, or you can
but then
study only the heat. Yeah,
are
tell me.
there instances when this console doesn't support this multi like for example suppose I'm working in a plasma module. So when
Okay.
I try to add when I'm working in plasma module
Uh-huh.
plasma when I try to add
Yeah,
a
I
heat
get it.
transfer to that when I
Okay.
when I try to add heat transfer Sometimes it transferred by radiation. Since the input values are not similar, it doesn't multiphysics doesn't work.
Like you have added the heat transfer physics and how you are I mean
I
already heat is
but
generated
they are not getting
you
coupled.
uh, you want to measure the temperature from
Yes.
all the step, I mean, did you specify that boundary condition properly in your study, like in this heat transfers section? Have you
Uh,
entered all this? I mean, maybe you have to check with all the whether you have applied the proper boundary conditions and the like specified. You need to measure right the temperature. You are not
yes,
able.
yes,
Yeah, you were
yes.
not able to.
Input, the inputs that I'm giving are voltage and current
Okay.
to the plasma. So
Uh-huh.
when I try to add this heat transfer to that,
Mm-hmm.
I feel it is because that the inputs doesn't match. Heat transfer we have to give temperature as the input, right? So I that is why
Yeah,
these two
actually,
modules are not getting coupled.
yeah, that also happen. And also that ambient temperature and all you have to set here. We can just, have you set
Pardon?
that all the settings like here? So I think all the boundary condition it has to match
Ah,
and
yes.
connect. Yeah, you just explore on that on
Okay.
those section. Yeah, just you have to just before adding
Uh-huh.
the multiphysics, just go for a simple modeling with the heat transfer and you can try what all. Then you will come to know
Uh,
what you have. Yeah,
okay.
then we'll see.
Okay. Okay. Thank you, madam. Thank you.
Any more queries?
Hello.
Yes.
Hello, madam. Thanks for your nice
Uh,
presentation. I am
Thank you
Agi,
so much.
madam. Actually, I have a
Yes,
doubt
sir.
regarding can we do calibration of this particular can we do the calibration of particular geometry or because if you know that if you do any experiment, for example, heat
Mm-hmm.
transfer or any radiation kind of things, we
Mm-hmm.
have to think about consistency of the sample or how it be consistent, right? Can we do any analysis on that because we have to be assured that that should be consistent, right? So
Like
I mean any
here,
calibration, for example, if you do conduct any heat transfer experiment like in our IC
yeah,
engine
yeah,
lab.
I understood. Here for the calibration, we won't use that models because
Okay.
that real scenario experiment is an experiment. You have to do with that only.
Okay.
So, once your model is optimized, all the parameters, all the conditions, all the boundary, everything is you can't tell your model is 100% correct. Like you
Okay.
have, yeah, a lot of optimization will be there, and
Yes, yes.
yeah, it's you are creating a pseudo model.
Okay.
Like
Okay.
yeah, we can't go like internal plan. We can go and
Okay.
do all the sorts of experiments. So we're like studying what all intuition, what is the physics is going on. Like in acoustics also, we can see or we can feel all in the experiment itself. It's like here when I give the instant pulse. I can't see what's going
Okay.
on with my eyes. So here we
Hello.
usually do with the experiment, I mean, calibration. We with, do with those experiments.
Hello. Okay, ma'am. Okay.
Yeah,
So yeah, so the thing is like, so after getting like experimental value, we can just validate that experimental value with this
yeah,
particular value, right?
yeah. Like you will be having only a few sets or 10 sets of experiment data, but you
Yeah.
can generate 1,000 sets of experiment data, and
Okay.
also you will be comparing all those results like and which one is a correct model. Like you
Okay.
have an steel block and you are studying, you are giving a heat and you are studying. So
Yes.
the same model you are virtually modeling in your console or any software, and you are
Okay.
giving few parameters or few environment or boundary condition you may not be knowing while doing the experiments, but
Yes. Yes.
you can arbitrarily give and like trial and error. If many unknowns will be there, you can arbitrarily give and you can check whether your experiments are correct. So you can set and you can validate your experiment, and you can tell like, yeah, this my experiment and model is right. So these are all the conditions, these are all the parameters I will be using in my experiment, and getting the results. And you can set that value. So you don't need to do all those 1,000 experiments and get, and
Okay.
you may not, I mean, you can't able to do, right? So you
Okay.
can use this.
Yes. Yes. Thank you. Thank you, ma'am. Very much.
Yeah.
Thank you.
Thank you.
It's fine. Okay.
So if you have any queries, you can type in the it's also in the chat box also in discuss.
So if you have any other queries regarding the general topic also, you can ask. Okay, you can unmute or you can type in the chat box.
So I can help you or can share any knowledge you are having, or you can add some knowledge here.
I think if anyone is looking for doing research in IITs and all, I think he will be in a position to advise you.
Yeah.
So if anyone is looking for that like opportunities, you can ask because this is
Actually, many are not aware like we have this all opportunities. Actually, I was not aware. I came here for a big project and I explored all. Like you will be with the electronics background, you will be like shocked how I will be doing all this mechanical work or like like all here, all works are like interdisciplinary. We will be mixing this mechanical and civil and this biotech and the chemical. Like different collaborations are there, and in signal processing, all the data you are will be available will be from different fields. So like next to the stages like. Instead of confined to any field, you can explore different fields, and you can just try like without just trying. Like you just apply like you. Usually, we will be thinking like these IITs are not for us, and all. You just have a try and you will come to know. And you can not only you can try with the single, like if your background is from EC or mechanical, don't just apply for that. You can explore different fields like applied mechanics, other in engineering design and structural, ocean, and different fields are there. You can try that. You can apply at one instant. I think you can apply three departments and write the exams, and interviews will be there. And it's okay if you fail in the first time, but you will come to know. Like my suggestion is don't just self reject yourself. Like you can explore, and you have to explore all those just like um, restrict yourself in this like, studies and all. If you can try. Even if you have entered in some colleges and all, that's okay, but you can use from and have a try to this exams, interviews. Even if you do well, if you are in topper, that doesn't guarantee here. Like you should not disappoint. That's what my point, main point. Like if they have if the professors only in the specific departments, professors only deciding whether they have to take a candidate in the winter or summer fall, and like there may be there should be opening or many different professors will be in different field. My professor is in ND field, and some other professor will be focusing only on the ultrasound or acoustics or structure or different fields are there. So if they want that candidate or if they are like that, it doesn't if their rejection doesn't mean that you are not capable of doing research in the IIT. It's like many factors are there. So you can try not only in the IITs, NITs, IASC, many institutions are.
Madam, one more question. Actually,
Yes.
I have done my PhD from NIT Surakkal, so I
Oh,
am waiting
nice.
for my defense really. So,
Okay, okay,
why I
nice.
am asking this question? In my research
Uh,
work, what I have done, like I am like mainly concentrated on waste management, like how to convert like
uh-huh.
waste tires into energy. So
Oh, okay, nice.
I have developed one technology in order to refine that particular oil. So
Oh,
what we have done, like we have done only the experimental things, like so we
okay.
have not validated like
Uh-huh.
what we got. Like that's why I asked how we can couple this software with that. It will be a nice idea because in
Yes.
that particular reactor, like we
Mm-hmm.
have a heat transfer.
Mm-hmm.
Like there should be like heat transfer and different type of conduction, convection,
Mm-hmm.
etc.
Mm-hmm.
So I think like we can use this software for that purpose also. So in order
Yeah,
to
yeah,
validate,
yeah. You just don't I mean stop here your research. Like you can just explore. If you
yes,
are going to the next level, you just try with the
yeah,
modeling. Like nowadays,
uh,
all those studies are going on to the virtual mode. Like you create all those models and all. So if you
okay,
validate all your experiments and with
yes,
models, it will be very
that.
useful. And all the best for your defense.
Thank you, thank you, thank you, ma'am. Thank you. Actually, this software is it open access or we have to?
Yeah, actually, that license your institute should buy and give you.
Okay,
And here also it's very restricted usage. I mean, yeah, it's bit costly.
okay,
So
okay, okay,
that's
okay,
what.
ma'am. Okay,
Okay, thank you.
okay. All the best for your research too. Okay, okay,
Thank you, sir. Thank you.
okay, okay, okay.
Any more queries from the audience?
Yeah, if they have any queries, they can contact me further. No issues.
Madam, is there anyone working in plasma module in IIT?
Um, that I don't know. Actually, here research group, diverse research groups are there. You can find. I mean, as of my knowledge, I don't know anyone. Like
Huh.
in mechanical, many labs are there. So
All right.
mostly there will be works will be there.
Uh, uh,
Yeah, if you want, we
okay.
can search and find.
Okay. Okay.
So thank you all for the attending and
So,
sharing your knowledge. Yeah.
so
Yes,
if
sir.
you don't have any queries, I think we can wind up the session.
Okay.
So I would like to thank Madam for coming and delivering such a wonderful session. It was very good, and we would like to hear from you for the opportunities that's awaiting for the students in IITs and all.
Thank
Because
you all.
as a student, they will be thinking that it's a premium institute and it's very difficult
Yeah.
for them to get an admission at IIT. But you told that it's not like that. If anyone has the will to work hard, they could readily achieve that. So thank you for the information, madam. And I would like to tell one more thing. She's an alumni from Thalassery Engineering College, and I am also an alumni from Thalassery. And I can see some people are there from the Thalassery Engineering College also attending this session. That's why I am specifying that.
Yeah,
Oh,
it's
okay, madam.
nice.
Okay, thank you.
Yeah,
Thank you for
thank you for
accepting
the
our invitation
invitation.
and delivering the session.
Yeah,
Thank
thank
you.
you for the invitation. Thank you.
So, for the participants, we will be having an valedictory session at the in the afternoon, and I will be sharing the link in the WhatsApp group. And there will be a feedback form as well as a quiz will be shared to you via Google form. So, you can fill out that form with so you need to check the spelling and all because that will be used for generating the certificates. So please make sure that you are inputting the name, full name, as well as your college name. So that will be the certificate. And there will be some few questions from these sessions. So you can attend that quiz also. And after that, we'll be joining for just a feedback session, and we'll be winding the SCTB in the afternoon. Okay, so I would like you all to join in that afternoon session and also for filling those Google forms that's shared in the WhatsApp group. Okay, thank you all for joining. So we'll wind up the session now and we'll be joining in the afternoon. So we'll be sending the details in the WhatsApp group. Okay, thank you.